Okay, if you don't have a notebook yet, that's okay. Okay, but I would highly recommend having a notebook of sorts so that you can keep everything organized. So normally we'd like go through a page or two of notes. Then give you some time in class to work on your homework. Okay, next day, come back, do more notes, more homework, keep everything organized. Okay, if you can find graph paper notebook, that's great. I got this off Amazon. I would imagine probably came in a 2-pack for like $5 or something like that. Okay, this works fine. So we're going to go over a function machine and what that looks like. It's all right if your artwork isn't as great. Mine obviously isn't either. So we'll be dealing with these things we call function machines, where essentially we are inputting something into the machine and it produces an output. All right, this is just a visual of an actual machine, but essentially plugging something in, getting something out. So normally it'll look a little bit something like this. Okay, where you're given an input at the top, you're plugging it into a function, and that produces an output. So first thing you might notice is that we use f of x. I've never seen that before. It's the exact same thing as y. So maybe you're more familiar with, when you see y equals something. So if you see f of x equals 5x plus 3, it's the same thing as y equals 5x plus 3. Okay, it's just referred to as function notation. Okay, you'll see it a lot more over the next few years. It's just a more proper way to write it. So especially when you're dealing with functions and inputs and outputs, makes everything a lot smoother. Okay, but don't freak out if you've never seen f of x. You'll get used to it. But like I said, it's the exact same thing as seeing y equals. So a little side note over there. All right. So what this means is x is going to be our input. I'm sorry, 4 is going to be our input. It's always going to be whatever is up here. Okay. So when you are given the input, you're going to plug in for x and solve. All right, so in this case, plugging in 4. So we plug in 4 for x. We get 5 times 4 plus 3. 5 times 4 is 20. Twenty plus 3 is 23. So that is our output. So our input was 4. Our output is now 23. Okay, and the proper way to write that would be f of 4 equals 23. So our input is now going in right here. Our output is going to be that one. Okay. So again, we were given the input of 4. Okay, when you're given the input, you're just plugging it into x into your function and solving. So in this case, plugging in 4 for x, 5 times 4 plus 3 now. 5 times 4 is 20. 20 plus 3 is 23. So this is essentially stating if you have an input of 4, you're getting an output of 23 for this particular function. So second example here, input of -3, function of f of x equals 2/3 x plus 3. So same thing, we're looking for the output. So we're taking that input and we're plugging it in for x. So we get 2/3 times -3 plus 3. All right, multiplying fractions, 3 times -3 basically becomes -1. So 2 times -1 is -2 plus 3, which would give us a final answer of 1. So given the input of -3, we get an output of +1. All right, have you guys tried this one on your own? All right, good. So 2 is our input, so we're plugging that in for x. -3 times 2 plus 1 gives us -6 plus 1, which then give us an output of -5. So f of 2 equals -5. Cool. Sweet. Okay, so that's if you're given the input. So now let's talk about if you're given the output. Okay, so it's just basically doing the opposite. Okay, if you're given the output, instead of plugging in for x and solving for f of x, you're going to plug in for f of x and solve for x. Okay, so we're given the output of 5. We want to find whatever the input is. So instead of plugging in for x, we're going to take our output and we're plugging it in for f of x in the front here. So now we're going to have 5 equals 2x minus 1. Okay, so a little bit different, but essentially the same thing. Now we're solving for x. Add 1 to both sides. 6 equals 2x. Divide by 2. And we get x equals 3. It's the loudest carts in the history of carts out there. So now that we have, now that we solve for x, again, this is going to be our input. So we just write it as f of 3 equals 5. Just making sure we put them in the right spot. Okay, input always goes inside the parentheses there. Output's always whatever it's equal to. All right, so try these two examples on your own. First one where you're being given the input, second one where you're being given the output. All right, so walking around, a lot of people doing good. It's just little mistakes here and there. Look like a bunch of people who haven't done math in 4 months. All right, so first one, we're plugging in 10 for X. So we get 3 times 10 minus 7. So we get 30 minus 7. Output of 23. So f of 10 equals 23. Second one, you're given the output. So instead of plugging it in for X, we're plugging it over here on this side for f of X. So we have 11 equals negative 2X plus 3. Okay, we're going to subtract 3 from both sides. Get 8 equals negative 2X. Okay, and we divide by negative 2 on both sides. Remember, we divide by negative. Positive divided by negative gives us a negative. So X would then equal negative 4. So that would be our input. F of negative 4 equals 11. Any questions on that stuff? Inputs, outputs, we'll be practicing a lot more with those throughout the chapter, but as obviously something you can expect to see on your chapter test. Only thing that'll change, maybe the functions on the inside get a little bit more difficult, but the process itself is what it is. If you either have the input, you plug it in for X. If you have the output, you plug it in for f of X, solve for the opposite, and then just be able to write it in function notation. All right, so moving on to some a little different, working with what we call tile patterns. So tile patterns, you usually start with, they'll give you a figure 0, and then they'll move on to figure 1. And figure 1 is usually has additional tiles like so. So usually with tile patterns, they'll give you something like this, and they'll ask you for a few follow-up things. Like the first thing they'll ask you to do is to make a table. So with the table, one side of the table will be what figure number are you on? So figure number. And then how many tiles are in that specific figure? Okay, this kind of helps us develop the pattern that is occurring. So with the figure number, all it is figure 0, figure 1, figure 2, figure 3, figure 4. And we could keep going on as much as we needed to. And as far as the number of tiles, all you got to do is be able to count. 1, 2, 3, 3 tiles in figure 0. 1, 2, 3, 4, 5, 6, 7, 8 in figure 1. Figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and we should be able to recognize a pattern at least after those 3. Okay, as we go from 3 to 8, we've added 5. 8 to 13, we've added 5. So now we've identified the pattern. We should be adding 5 tiles between each figure. So we go from 13 to 18 to 23 to 28, so on and so forth. And we can recognize that in the pictures as well. We started off with 3. If we go back and look, okay, those 3 right there, I've added this one, this one, this one, this one, and this one. Okay, those are the 5 new tiles from the previous figure. Same thing in figure 2. I've added another one up, 2 more up top, 1 more to the right, and 2 more on the bottom. Okay, I can identify the new tiles each time. Okay, that'll help you draw the next figure as well. Okay, we'll come to that at the end. Okay, they'll ask you for an equation. That fits the tile pattern. Okay, if we're growing by the same amount each time, should be a linear function. Y equals mx plus b, or I guess I should just start using that. F of x equals mx plus b, where m is your, what are you adding each time? And b would be your tile, number of tiles in figure 0. All right, so how many tiles are we adding? Well, I've identified that we're adding 5 each time. Say f of x equals 5x. And then our b value is going to be however many tiles we had in figure 0. In this case, is 3. So we got our equation right there. Now, it's not always going to be linear, so we might have to adjust. Probably the most common one, however. Okay, and just being able to write in y equals mx plus b form. And the last thing they'll ask you to do is to make a graph. So on the x-axis here, we have our figure numbers. Y-axis is going to be our number of tiles. We can just even reference back to our table. Figure number 0, we have 1, 2, 3. Put a nice little dot there. 1, we got 8, or we can just count up 5. So we got 1, 8, and then 1, 2, 3. You don't have to put them all down. I'm just kind of have a little extra space up there if you don't, as long as you get the first few anyways. And then more importantly, I'm not going to connect them. Okay, I'm just going to leave them as dots. Okay, the reason is if you drew a line between them, that's implying that there would be like figure number 2.7, which doesn't really make any sense, or that you could have, 7.5 tiles, which again doesn't make any sense. So really only want to stick to the whole number. So we're just going to plot the points. We're not going to connect them. All right, the last thing they'll make you do is draw the next figure or two. Just draw the next one. Okay, so again, being able to identify where are we adding the tiles is helpful, because all you really need to do is copy the previous figure, okay, and then add the new ones around it. So in this case, I'm just going to copy this straight over. I got, let's see, 2 up top here, 2 more underneath, 5 goes across, and then 2 rows of 2 underneath. Okay, so I've just copied figure 2 to figure 3. I've identified the pattern. I'm going to add another row of 2 up top, another row of 2 on the bottom. Okay, and then 1 more out to the right there. So that would be the next figure, figure 3. All right, so let's have you guys try one of these on your own, given this tile pattern. Okay, so you're going to want to make a table. You come up with an equation. Okay, and then graph it as well and find figure 3. Okay, so what was figure 3 going to look like as well? All right, so coming up with the table. Okay, our figure number 0 has 1 tile, figure 1 has 5, figure 2 should have 9. Okay, so we kind of pick up on the pattern, understand that we're adding 4 each time. So we get 13, 17, 21, and so forth. So that makes our equation f of x equals, well, we start with our 1. That is our starting value, and we are adding 4 each time. So f of x equals 4x plus 1. Making our graph 0, 1, add 4 each time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Guess I could have done a better job and labeled this. All right. And then lastly, coming up with figure 3, I'm adding 4 to each corner. We're at 1 to each corner for a total of 4 each time. So for figure 3, I'm just going to copy this one over. Like so, and then add 1 more to each corner like I'd been doing. So that would then be the next figure, figure 3.